going to be a question about homogeneous versus heterogeneous mixtures. Homogeneous mixtures, everything looks the same all the way through. And in a heterogeneous mixture, you can actually tell the substances apart. So I've got a heterogeneous mixture of different kinds of metal shot here, and a homogeneous mixture of copper sulfate solution. Okay, and I'll show you other examples in class tomorrow. 25 examples of compounds. Compounds are chemically bound together. It'll actually reference that in the question. Are the gases in air chemically bound together? No. Air is a mixture. It's a homogeneous mixture because we can't see the parts, but it's a mixture. How about the elements in water?
Yes.
Yes, those are chemically bonded together to make water. So the first one, they're both homogeneous. They're both colorless and clear. We can see through them, but one is a mixture, one is a compound. Okay, and you'll have another couple of answer choices that are similar to that. 26. I actually showed you this question in the practice test. It's the one with the periodic table, and I asked you about a couple elements in the same column. And what do we know about elements in the same column on the periodic table? They share the same number of valence electrons, and that gives them similar what? Properties.
We didn't see both of those then?
It might have.
So
Right.
share what?
Oh, it said the same number of orbitals on the pretest, and it's the same number of valence electrons, not the same number of orbitals. So the same number of valence electrons, same properties, or similar properties. Okay, and you know where the really reactive elements are on the periodic table? The edges. The metals are really reactive on the left, the nonmetals are really reactive on the right, except for what?
Noble gases.
The noble gases, which are way to the right, and they don't react at all, as far as we know at Chem 1 level. We'll find out later that some of them do react. All right? What are the columns on the periodic table called?
Families.
Families, and what else? Groups. This is sweet because it's written right on the table up there, isn't it?
Yeah.
Yep. We're up in the upper corner by hydrogen. It says group above the column and period along the side. So your free answer right there on the periodic table, right on the wall. Alrighty, 29. My hint says the properties of nonmetals, and this is going to be one of these, which of the following is not a property of nonmetals? So you need to know the differences between metals, nonmetals, and metalloids. And between today and your test at the end of the week, we're going to be doing some activities in class to help you distinguish those. I know it might not be coming to mind right away right now. We'll be doing some more investigation of that. Metals are usually shiny. They conduct heat and electricity. They're solids except for mercury. They have tenacity. The particles stick together. They're malleable, which means we can hammer them. As opposed to nonmetals, which tend to be brittle, or even they're liquids or gases. They don't conduct heat, they don't conduct electricity, and then you've got the metalloids in between. The metalloids are semiconductors. They tend to be more like nonmetals, but they can't conduct electricity. That's the one metallic property that they share. Okay? Oh, so that actually covers 30 also. And 31, what the different numeric safety codes on a chemical label mean. So that goes back to that little booklet, this booklet that we worked on in class together. And these safety symbols. Okay? And we have anything from 0, meaning minimal hazard, all the way up to 4, which is severe. Okay? So we have a number ranking code from 0 to 4, minimal, slight, moderate, serious, and severe. Okay? And then each color tells us something. Red is the fire, yellow is reactivity, blue is health, and white is any extra information necessary. So red being fire is easy. Yellow reactive, blue health. And white is there if there's any particular special hazard for that.
The higher the number, the more dangerous.
The higher the number, the more dangerous, but the max it can be is 4. So if an answer choice says 6, you don't want to pick that one. Just saying. 32, the proper way to filter a solution. When you're pouring a solution into a funnel to filter it, what do you do to make sure things don't go splashing all over the place? Slowly, and there's something in the picture in the lab 1 with a stirring rod. You're going to hold a stirring rod against the lip of the beaker so that the liquid has a trail to run down. Okay? That's right from the picture in the lab. Alrighty. What instrument is best to use for measuring a specific amount of liquid? Okay, the very best device we have is what for exact liquid measurements? Burette. Very big skinny burette. What's the next best thing? Graduated cylinder is third in line. A pipette, but not the plastic ones that we've been using. The actual glass volumetric pipettes. Volumetric pipettes are made to hold one specific amount only. So if it's a 50 milliliter pipette, there's 1 mark on it, and when you fill it to that mark, you got 50. If it's a 10 milliliter pipette, it's got 1 mark. You fill it to that mark, you've got 10 milliliters. So that's all they can measure. So you have to have a whole bunch of different kinds. Which is why we usually use the third best thing, the graduated cylinder, because it has several marks on it, and we can use it to measure. For our purposes, that's our most specific. Alrighty, the next questions are short answer. And the first one is about classifying and distinguishing physical and chemical changes. And I will tell you a substance, and I will tell you something that's happening to it. And you're going to tell me which part of the changes are physical and which part are chemical. Okay? And it will be something where both will happen. 35, differentiating between pure substances and mixtures. The question says, explain the difference between a pure substance and a homogeneous mixture, with some examples. So that's a great example of where the test hint is almost telling you word for word what the question says.
Wait, I'm 35.
Yeah. Now, we have not spent too much time on examples yet, because we had to put this current lab up earlier in the week. But we're going to be going over some of that stuff again tomorrow. And then your classification inquiry activity will help you with that a lot, that you're going to be doing Wednesday. Okay. 36, relate chemical activity to location on the periodic table. We kind of talked about this with the question about what is similar in columns. Where on the periodic table are the elements that don't want to react with anything at all? The noble gases. The middle ones react, but not as much. The ends are the extreme, the middle is kind of evens out, and then the very end, the very rightmost end, where the noble gases, column 18, those are the ones that don't react at all. Okay? And 37 expands on that and asks you to explain what happens to properties as you go across the periodic table. And again, the classification activity that you're going to be doing